Dear student, next we see that another two topic in this video actually that is for hyperconjugation effect and another one is electromeric effect. Let's see that is one by one. First case there is a hyperconjugation effect. This also called there is a Baker-Northern effect. Baker-Northern effect. Okay. So this Baker-Northern effect, this Baker-Northern I have proposed in this effect. That's why its name is came Baker-Northern effect like that. Okay. So this hyperconjugation effect is a delocalization of the sigma electron in converted into pi electron. Here this for sigma electron to there's a pi bond. Okay, sigma electron is converted to pi bond, or that's for pi electrons. Okay, so in generally the electronic migration or reactivity, the electrons of reactivity there is based on there is a lone pair electron is greater compared to the bond pair. For this bond pair there is a pi electron is greater than the compared to the sigma electron, like that we studied in the previous video. Okay, so now the hyperconjugation means there is nothing but there is a migration of the carbon hydrogen, that is for carbon hydrogen sigma bond. Okay, migration of carbon hydrogen sigma bond for there is a delocalization. There is a delocalization or there is a migration, like that we can say here. There is a delocalization of a carbon hydrogen sigma bond into that pi bond. That is for that hyperconjugation. Where that hyperconjugation is possible. Actually, the carbon hydrogen sigma bond is delocalized with empty p orbital or unshared p orbital. Okay, there is a unshared p orbitals. There is a adjacent of the unshared p orbital. If it's contained that carbon hydrogen sigma bond is delocalized, we can get in that the pi bond. That is nothing but for that hyperconjugation, or there is a Baker-Northern effect. Okay, so for example, the hyperconjugation is occurred in the case of alkene, and there is a carbocation, and there is a free radical. Okay, free radicals. Those only involved in that hyperconjugation effect. The remaining anywhere we cannot see this hyperconjugation. So this alkene, carbocation, and free radical, they are only involved in that hyperconjugation. For example, that see there is a C in the case of the carbon hydrogen bond is delocalized, like that we told you past 2 minutes. Actually, there is a alpha hydrogen. Such alpha hydrogen is directly proportional to of the hyperconjugation effect. So see in the case of C plus here is a CH3 and CH3 and CH3. So this is the functional part of this species. So that's why this containing this carbon, such carbon is a alpha carbon, and this also is alpha, this also is alpha. We can separate it here alpha dash and alpha double dash, like that. Okay, so it possesses that alpha hydrogen. Okay, so this alpha hydrogen it possesses the acidic character. So what happened? These two hydrogen, one hydrogen is representing here. This bond shifted here. We can get in that the another one isomers of here CH3 CH3 double bond CH2 here is a H plus. Okay, so similarly, so each methyl group containing 3 hydrogen. Okay, each methyl group is containing 3 hydrogen. So the 3 methyl group is there. So 3 into 3 what? That is equal to 9. So 9 hyperconjugative isomers are possible. The parent compound, even if we added here 9 plus 1, that is equal to 10 isomers are possible. For example, see the CH3 CH2 plus. This is a primary carbocation. Here this for alpha carbon, here is alpha hydrogen as a 3 alpha hydrogen. Okay, so these can be representing CH2 hydrogen single bond CH2 as a plus. Okay, so this this carbon hydrogen sigma bond can be converted into pi bond. When that is occurred, that adjacent of empty p orbital, or there is an unshared p orbital. Okay, so here this carbon has sp3 hybridization and this carbon has sp2 hybridization. So this initially we teach it in the GOC unit, in this unit. Okay, so whenever that a carbon is bonded with a 4 sigma bond, that is for sp3 hybridization, and if the carbon has 3 sigma bond only, that is for sp2 hybridization. Okay, the sp2 is carbocation. Here there is a unshared p orbital is possessed. So here this carbon hydrogen sigma electron can be shifted here. Okay, so what did happen here? There is CH2 double bond CH2, there is hydrogen as a plus. So similarly the remaining 2 hydrogens also like that happened. So for this molecule there is a the 3 hyperconjugative structure plus 1 as a parent structure. That's totally 4 isomers are possible. Okay, 4 hyperconjugative structures are possible. Okay, then next we go to that the free radical. There is CH2 or CH3 CH2 dot. Okay, so this carbon has a sp3 hybridization, and this carbon has a sp2 hybridization. So whenever that this carbo free radical as well as previous carbocation both possess as a sp2 hybridization, just is nothing but is changed the add electron species for free radical and even electron species for carbocation. That's all. The remaining part is nothing to change. It possesses a magnetic moment and paramagnetic nature, like that, etc. Okay, so this also there is a unshared p orbital or vacant p orbital. So we can go to that the representing CH2 hydrogen single bond and CH2 dot. Okay, so this bond is go to that homolytic bond cleavage. The one electron can be shifted here, and this electron can be shifted here, and the remaining one electron goes to here. What did happen? Here there is CH2 double bond CH2. Here is a H dot A. Okay, see in this molecule also it possesses a 3 plus 1 iso structures. Okay, so this is the 3 alpha hydrogen based on that 3 hyperconjugation, and this parent compound 1, there is 4 compound we can get in. Okay, the next category, there is alkene. See, there is CH3 CH double bond CH2. Here this alkene carbon, both it possesses as a sp2 hybridization, and this carbon as a sp3 hybridization. What is nothing but in the hyperconjugation, there's a carbon hydrogen sigma bond is electron completely transferred into that the pi bond of adjacent sp or sp2 unshared pair of electron containing unshared orbital. Okay, so this can be representing CH2, there is a hydrogen, there is single bond CH double bond CH2. So now this sigma bond shifted here, and this pi bond shifted here. What did happen? This actually, there is a CH2 double bond CH2 minus. Okay, CH2 minus. So now what did happen? This hydrogen, it possessed here is a positive charge. So this molecule it containing this 3 alpha hydrogen. There is a alpha hydrogen is equal to 3. So similarly there is a 3 plus 1 we can get it. Okay, so in order overall there is a methyl group. Here we can see there is a carbocation only. There is a similar like that. There is a alkene and free radical is also. It cannot. So there is a hyperconjugative effect. So the next there is CH3 CH2 plus. This occurred in the 3 alpha hydrogen. There is a 3 alpha hydrogen. Okay, so the next category CH3 CH plus. Here is a CH3. Here 3 hydrogen and 3 hydrogen. There is a alpha hydrogen is equal to 6. The next category, there is CH3, CH3, CH3. Here is a positive charge. So this carbon, it containing 3 hydrogen and 3 hydrogen, 6. 6 plus 3, there is a 9 alpha hydrogen. There is alpha hydrogen is equal to 9. Okay, so this all are that, this 3 all are possessed, there is a alpha hydrogen. So it is gives in the hyperconjugative effect. But this methyl cannot possess, there is a alpha hydrogen. It cannot, so there is a hyperconjugative effect. Okay, so simply saying the hyperconjugation means the carbon hydrogen sigma bond is converted into there is a pi bond. Next, there is a application of that effect. There is a application. This application of effect. There is a stability. Stability is directly proportional to the number of alpha hydrogen. Number of alpha hydrogen, as well as there is a stability is directly proportional to number of canonical structure. There is a canonical structure. So there is a major important. For example, the stability of carbocation and stability of free radical, those are that directly proportional of that hyperconjugative order. Okay, so there's a more number of hyperconjugative effect that is directly proportional to stability of carbocation and the stability of free radical. Okay, so there is a very important. If there is a more number of the hyperconjugative effect, when it possesses, whenever that is a alpha hydrogen is increases, the hyperconjugative effect also increases. For that reason, there is a carbocation and free radical, they have, there is a greater stability, as well as the stability of alkene. There is a heat of hydration inversely proportional. There is a heat of hydration. This we will study. There is a hydrocarbon unit. Okay, heat of hydration, there is a inversely proportional to of there's a stability of alkene. Okay, so whenever that the stability of alkene is directly proportional of there's a alpha hydrogen, there's a stability of the alkene as a directly proportional to for there's a alpha hydrogen containing molecule. Alpha hydrogen is a containing molecule. Okay, for example, see here there's a CH3 C double bond CH3 C CH3, and here is a CH3. So this is for that olefin. It is a functional group. So this group is containing this methyl, both the 4 methyl group are considering as a functional group. Whenever that functional group containing carbon, that's a alpha carbon that is containing for alpha hydrogen. Here that is for there is a 12 hydrogen is there. Alpha hydrogen is for 12 hydrogen. So that's why there's a more stable. And similarly, the CH3 CH3 double bond CH3. Here 1 2 3 3 into 3, that is for 9 alpha hydrogen. So alpha hydrogen is for 9 alpha hydrogen. So that's why there is a second category. Okay, so and that is a CH3 CH double bond CH or CH3 and hydrogen. So here this methyl group and this methyl group are opposite direction. That's why there's a cis isomer. Okay, so this is the most stable compared to that. Sorry, that's for a trans. It's a trans isomer. Opposite means there's a trans isomer. This is the most stable compared to that. There's a CH3 CH double bond CH. Here these 2 methyl group are same side. So there is a cis isomer. So among these 2 is the trans is the most stable compared to the cis. Okay, so both it contains there is alpha hydrogen. There is 6 alpha hydrogen, and last one CH3, CH double bond, CH2. Here is alpha hydrogen is equal to 3. Okay, anyway, the number of the alpha hydrogen increases, the stability also increases. Next we go to that electromeric effect. Okay, it's a electromeric effect. This electromeric effect actually, there is a temporary effect. There's a temporary effect. Temporary effect. Okay, so this is having that unsaturated compound, or there is a multiple bond, a compound, it has unsaturation, or there is a multiple bond. Okay, multiple bond. Multiple bonds means there is a more than one bond. Whenever that among the carbon, more than one double bond, more than one bond, that is under the category of unsaturation. So this is separating. There is two types. One is for plus E effect, and another one is for minus E effect. So this is nothing but the unsaturated compound, they have gained the electron pair from the attacking species. That is nothing but minus E effect. For example, the CH3 CH double bond and CH2, that's a propene. We added that HX. So this X is a minus, here is H as a plus. So we can get the product as a CH3 CHX and CH2, like that. Okay, so this product as a major product, and also there's a minus product is possible. Here there is a first case as a minus E effect. So the minus E effect, there is a the electron or pi electrons of the multiple bond, the pi electrons of the compound, or pi electrons of compound, they have gained or transferred that atom, or the multiple bond or transferred to that to the upcoming atom, the pi electrons of compound transfer to coming or attacking, or there is a attacking atom or species, there is a species. Okay, for example, it is for that nothing but the minus E effect. Here there is C carbon double bond carbon, and here CH3 as a hydrogen. So this is for 2-methyl butene, this molecule. Here for example, the Cn minus A, this goes to attack here, this bond go up. So what we can get, the CH3 single bond CH3 Cn hydrogen, here is a minus. Okay, so after that it's a gain of proton. We can get the neutral species. After that it can gain the proton. We can get that as a CH3 CH3, and here is a hydrogen as a Cn. This is a molecule. Okay, next there is a plus E effect. Okay, the plus E effect, the pi electrons of multiple bond or gain the electron from the upcoming atom, or the pi electrons of compound, there is a gained to the compound or attacking atom or species. Okay, for example, same compound CH3 double bond CH3 as a hydrogen, here added that the electropile, for example, as a H plus. So now this pi electron is going to gain this proton into this carbon. So what did happen? The CH3 single bond here is a plus, and CH3 hydrogen. Okay, so now, okay, this for the secondary 2-methyl group, and this group is containing. So there is a tertiary carbocation. Okay, so this gain that X minus, we can get the compound of CH3 X CH3 Okay, so in this case, based on that, there is a this electron deficient electrophile is coming to attack this carbon. So this pi electron shifted to the making a bond between this carbon and hydrogen. So that's why this for that the plus I effect. Okay, so in the overall application point of view, the acidic strength and basic strength, whatever that, first case the acidic strength is directly proportional of this Ka, and directly proportional of electron withdrawing group, and directly proportional of minus I effect as well as minus R effect, and the inversely proportional to for pKa, and there is a electron donating group and plus I effect and plus R effect. So this is for the very important for that acidic character, and also there is a basic character. Okay, what did happen? There is a base strength is directly proportional of Kb, directly proportional of electron donating group, and plus I effect plus R effect, inversely proportional of that pKb, and electron withdrawing group minus I effect as well as minus R effect. That's all. So apart from this, none of the questions asking. Okay, mostly this is a covered. Okay, thank you dear student. If you like in this video, you can subscribe and share your friends. Thank you very much.